Welcome back, everyone, to the Deep Dive. Today, we are diving into a topic that can really help you unlock the full potential of your data. We're talking about a way to do calculations across related rows of data. But a key here is that we're not going to lose sight of all those individual details.
That's right. So it's kind of like going beyond just the simple summaries and looking at the bigger picture. But at the same time, we're keeping all of those specifics right in front of us.
Exactly. I mean, think of it this way. Imagine you could rank items within certain categories, calculate running totals so you can see how values add up over time,
Mhm.
or even smooth out data because there's a lot of ups and downs using moving averages. And the coolest part is that you get all of this without sacrificing the details of your original data.
Yeah. I mean, think about it. It's all about being able to see these insights. But like you said, without having to just mush all your data together or summarize it away, you're keeping all the details.
And the secret weapon for all of this, it's a set of tools called window functions. The sources we dug into today are all about how these functions work within SQL, which is structured query language, the language that drives most databases. So if you're a data pro, or even if you're just curious about how this data analysis stuff actually works, this is for you.
For sure. And, even if you've never written a single line of SQL code, the ideas behind window functions are super valuable. I mean, just understanding how you can analyze any kind of data that has a sequence or that's grouped naturally. The idea of like drawing a window around related data points and then doing calculations within that window, that's a fundamental concept.
That's a great point. So for this deep dive, our goal is pretty simple. We want to understand what these window functions are, how they actually work behind the scenes, and then how we can actually use them. And we'll look at both the common ones and some of the more advanced types. So starting with the basics, what exactly are these window functions?
Okay, so basically a window function does calculations across a group of rows that are connected in some way to the specific row that you're looking at. And the thing that makes all this possible is the over clause. This is what defines that window, the group of related rows that your calculation is going to work on.
So it's not just looking at a single row in isolation. It's taking into account other rows in the data as well, right? That sounds pretty different from the normal way we think about calculations. Like, how does it differ from those aggregate functions that we use all the time?
Yeah, great question. Think about functions like sum, avg, or countout. These take a bunch of rows and they kind of squash them down into a single row, a summary. Like if you calculate the average sales for the whole year, you get one number and you lose all the details about how much you sold each day. Window functions, they work differently. They do a calculation for each row, but that calculation considers the window of other rows. But the big thing is they don't change the original data. So every row in your result still matches up to a row in your original data. You just have this extra calculated value tacked on.
Got it. So we get to keep all the details, but gain this added layer of understanding through the calculation. Can you give us a real-world example to help visualize how this actually looks in practice?
Definitely. Let's say we've got an employees table with info like their name and their salary. Now, if we want to rank our employees based on how much they earn, we can use the rank window function. The query would look something like this. Select name, salary, rank, over, order by salary DC, as salary rank from employees.
Okay, let's break that down a bit. We select the employee's name, their salary, and then we use the rank function. So what's the over clause doing in this case?
That over order by salary DC part, that's our window.
Yeah.
So here it's essentially saying, look at all the rows in the employees table. And then the order by salary dissociation is telling SQL to rank based on the salary column, but in descending order. That means the highest earners are at the top. So the result you get is a list with every employee, their salary, and their rank compared to all the other employees. It's incredibly useful if you want to see like who your top performers are.
Right, so you see where each person stands in the company, not just their individual salaries, like you said earlier, a bigger picture. And the source material highlighted how ranking, running totals, and moving averages are common uses for window functions. So that gives us a good sense of some practical benefits.
Absolutely. These are just a few of the most common window functions. They really show off that key advantage of window functions, analyzing data across related data points without getting rid of the details. So now that we have a good foundation, let's explore some of these common functions in a bit more detail.
Sounds good. Let's start with row number. What does this function actually do?
Row number is pretty straightforward. It basically does what it says. It assigns a unique number to each row within the window that you define. The order of these numbers depends on the order by clause you put inside that over clause.
Okay. So if we wanted to give each employee a sequential number based on their salary, how would we write that?
You would use this query. select name, salary, row number, over, order by salary desk as row num from employees. So here, order by salary desk C, make sure the highest salary gets row number 1, then the next highest gets 2, and so on. It's a simple way to put things in order and give each row a unique identifier based on that order. Useful if you want to pick out the top record based on some criteria.
Nice and simple. Now, we already talked about rank a little bit. Could you remind us how that function works, especially when it comes to handling ties in the data?
Sure. Rank assigns a rank to each row, like we said, based on the order you specify. The big difference from row number is what happens when you have identical values. If 2 or more rows have the same value for the column you're using to rank, they get the same rank. But here's the catch. It creates a gap in the ranking. Like if 2 employees are tied for the highest salary, they both get rank 1, but then the next person will have rank 3, not 2. So you see the ties clearly, but you might have gaps in the sequence of ranks.
I see. So there might be missing rank numbers because of those duplicate values. That's something important to remember. The source also mentioned dense rank. How does that one compare to the regular rank function?
Dense rank is kind of like rank in that it gives the same rank to rows that have identical values. But here's the key difference. It doesn't skip any ranks. So let's say you have those 2 employees tied at rank 1. With dense rank, the next employee would get rank 2. You always have a consecutive sequence, even with ties. It can be useful when you want to rank things fairly without penalizing people because of a tie higher up.
So if you want to avoid those gaps in the ranking, even when you have duplicate values, then you'd use dense rank. That's a subtle but important difference depending on what you're analyzing. What's next on our list of common window functions?
The next one is NTILE, Arauna. This function basically lets you divide the rows in your window into a specific number of groups, which we call buckets. Each row gets assigned a bucket number telling you which group it falls into. This is really useful for understanding how your data is distributed.
That sounds perfect for categorizing things. Got any practical examples of how we might use NTILE?
Sure. Let's say we want to divide our employees into 4 groups based on their salaries. Like we want to see the salary quartiles. The query would be something like, select name, salary, NTILE 4, over, order by salary .cc, as quartile from employees. This would order everyone by salary, highest to lowest, and then assign a quartile number to each employee, either 1, 2, 3, or 4. Roughly 25% of employees will end up in each quartile. It's a good way to see those salary brackets or to group employees for further analysis.
Nice, so you can see at a glance where everyone falls within the overall distribution. And lastly, the source mentioned that you can actually use normal aggregate functions like SEM, AVG, and count as window functions. How does that work? Just by using the over clause.
Yeah, this is where things get really flexible. When you stick an aggregate function with the over clause, it calculates that aggregate across the whole window that you define. But it does it for each individual row. Like, let's say you want to see each employee's salary and also the average salary for all employees. The query would be select name, salary, AVG, salary over, as AVG salary from employees. Notice there's no order by or partition by inside the over here, so the window is simply the whole employees table. The average salary will be calculated across all employees and then shown on every single row. That way you can immediately compare each person's salary to the average.
That's so useful. You can immediately see who's above or below the company average.
Yeah.
Now, you also mentioned something called the partition by clause earlier. How does that fit into all of this? Does it make window functions even more powerful?
Yeah, partition by is a really cool addition to that over clause. It lets you split your data into smaller groups called partitions. Then the window function does its calculations within each of these partitions separately. It's kind of like resetting the window for each group. This opens up a lot of possibilities for more focused analysis.
Can you give us an example of when you might want to use partition by before applying a window function?
Let's go back to our employee salary ranking. What if you wanted to rank employees by salary within their department, not just across the whole company? You could use partition by department. So the query would be something like, select name, department, salary, rank, over, partition by department, order by salary DECC as depth salary rank from employees. Now, the rank function is applied separately for each department in your table. You essentially get departmental leaderboards, which might be more relevant than a company-wide ranking.
That makes so much sense. So you get those localized rankings or averages that are specific to certain categories in your data. So we've covered the basics, what window functions are, how the over clause works, and common functions like row number, rank, dense rank, and tile, and using aggregate functions with over. Oh, and the partition by clause too. Now let's move into those more advanced applications, like those running totals and moving averages. I think this is where it gets really interesting seeing trends over time or in sequences.
You got it. This is where you really start to unlock the power of window functions for analyzing data that has a time component or some kind of sequence. Let's start with those running totals you mentioned.
Okay, so how can we use window functions to calculate running totals?
The key is to use the SEM aggregate function together with the over clause. But there's one more important piece. You need an order by Y clause as well. Imagine you have an orders table with columns for the order date and the revenue from each order. To calculate the running total of revenue over time, ordered by the date, you would use this query. Select order date, revenue, SUM revenue, over order by order date as running total from orders.
So basically, as you go down each row ordered by date, the SEM function isn't just adding up the revenue from that day's orders, it's giving you the total of all revenue from the very beginning, up to and including that date.
Exactly. So for the very first date in your table, the running total is just the revenue from that day. But then for the second date, it's the sum of revenue from the first day plus the revenue from the second day and so on. It's a great way to visualize how your revenue is growing over time.
Yeah, like a visual representation of how the business is progressing. Now, what about those moving averages? They seem like a really helpful way to smooth out any short-term fluctuations in the data and see the underlying trends.
Exactly. A moving average gives you the average value over a certain window of rows. You can include rows before and sometimes even after the current row. To do this with window functions, you use the AVG aggregate function with the over clause. But here's the key part. You also use this thing called the rows between clause inside the over. This lets you define exactly which rows you want to include in your moving average calculation.
Rows between. Can you explain how that works? How do we actually use it to define the window for our moving average?
With rows between, you get to be specific about which rows to include in your calculation. It's all relative to the row you're currently on. So let's say you want a 3-row moving average for revenue ordered by order date. Your query might look something like select order date revenue AVG revenue over order by order date rows between 2 preceding and current row as moving average from orders. What that means is, for each order date, you're calculating the moving average by taking the revenue from the 2 orders that came right before it, plus the revenue from the current order, and averaging those 3 values. This smooths out any daily spikes in revenue so you can see a more general trend.
Got it. So rows between 2 preceding and current rows sets up that window of 3 rows for calculating the average. What other options do we have when using rows between?
You actually have a lot of flexibility. You can say how many rows you want before the current row, like we did with 2 preceding, or how many rows after using following, or you can use both. You can also use keywords like unbounded preceding to include everything from the start of your partition up to the current row, or unbounded following to include everything from the current row to the very end. And of course, current row refers to the row you're on. Unbounded preceding is particularly useful for calculating running totals from the very beginning of a group, like the total amount spent by each customer.
Which brings us back to those cumulative sums. The source mentioned that too. Is that basically just a specific way of using rows between?
Exactly. A cumulative sum is basically a running total that starts from the very beginning of your data set. You do it using the sum function with the over, order by clause, and then specifically defining your window with rows between unbounded preceding and current row. For that orders table example, it would be select order date, revenue, sum revenue, over order by order date rows between unbounded preceding and current row as cumulative sum from orders. That unbounded preceding part ensures that you're always adding up everything from the start.
So whether you're looking at running totals over a specific period, like with a moving average, or you want the total accumulation from the very beginning, these window functions with over and rows between are really powerful for analyzing trends over time or any kind of sequence. Now, to really bring this home, let's get practical. You mentioned managing a database for an online store. How would we see these concepts play out in a real-world scenario like that?
Okay, imagine we have an online store, and we have a couple of key tables. A products table that has details about each product, like how many have been sold, and an orders table with information about each transaction, like the date and the revenue it generated.
Pretty typical for an e-commerce business.
Right. So first, let's say we want to see which products are our best sellers. We could rank them based on their sales using that rank function. Select product name, sales, rank, over, order by sales SC as sales rank from products. This gives you a quick view of your top sellers, which might help you decide on things like inventory, marketing, maybe even new product development.
A very straightforward and useful application. What about if we wanted to track the overall financial performance of the store, like how revenue is growing over time?
Then we could use that running total calculation we talked about, applying it to the orders table. Select order date revenue, SIGM revenue over order by order date as running total from orders. By looking at this running total day by day, you can see the growth trajectory of your business. It can also help you see the impact of things like marketing campaigns or seasonal trends.
And what about when you want to see more recent performance trends, like smooth out those day-to-day fluctuations to get a better sense of how things are going?
You got it. You could calculate something like a 7-day moving average of your revenue. Select order date revenue, AVG revenue, over order by order date rows between 6 preceding and current row as moving guide from orders. This gives you a smoother view of revenue over the past week. It helps to filter out any single day spikes or dips so you can focus on the overall direction.
I love these examples. They make it so much easier to understand the value of window functions in the real world. Now, our source material also included a section with interview-style questions and answers. Let's run through some of those to review and solidify what we've learned. First up, can you give us a basic definition of a window function and explain how it works?
Sure. A window function basically performs a calculation across a set of rows that are related to the current row. The over clause defines this window, the group of related rows. Unlike those regular aggregate functions, window functions don't squash your data down. You get a calculated value for each row based on the window.
Perfect. Next question. What's the difference between how rank and dense rank handle ties in the data?
Okay, so both rank and dense rank assign ranks to rows based on an order that you set. The main difference is in how they handle duplicates. With rank, if you have ties, all the tied rows get the same rank, and then the next rank is skipped. So if 2 rows are both ranked 1, the next one will be ranked 3. But with dense rank, it also gives the same rank to tied rows, but it doesn't skip any numbers. So if 2 rows are ranked 1, the next one is ranked 2.
Very clear.
Hmm.
And how would you go about calculating a running total in SQL using a window function?
For a running total, you'd use the SUM aggregate function with the over clause. And inside the over clause, you'll need an order by clause to determine the order in which the total should accumulate. For example, to get the running total of revenue by date, you'd use select order date revenue, SUM revenue over order by order date as running total from orders.
What about calculating a moving average? What are the essential parts needed for that?
To calculate a moving average, you use the AVG aggregate function with the over clause. Like with the running total, you'll need an order by to set the order. But for a moving average, you also use that rows between clause inside the over. This lets you control how many rows before and possibly after the current row are included in the average. So for a 3-day moving average of revenue, it'd look like this. Select order date, revenue, AVG revenue, over, order by order date rows between 2 preceding and current row as moving give from orders.
Okay, and what exactly does the partition by clause do when you're using window functions?
Partition by is used to divide the data into separate partitions based on the columns you specify. So when you use a window function with partition by, the calculation happens independently within each of these partitions. It's like starting a new window for each group. That way you can do calculations specific to each category in your data.
So if we wanted to rank employees by salary, but separately for each department, how would we write that SQL query?
You would use the rank function with the over clause, and inside that clause, you would use both partition by department to separate the rankings by department and order by salary to rank within each department based on salary. It would look like this. Select name, department, salary, rank, over partition by department, order by salary as salary rank from employees.
How would you go about calculating a cumulative sum, starting from the very beginning of your data set and continuing for each order?
To calculate a cumulative sum from the very beginning, you'd use the SE function with the over clause. You would order the data by the relevant date or sequence, like order date, and then you would use rows between unbounded preceding and current row. This makes sure that all the rows before the current row are included in the sum. The query would be select order date, revenue, sum revenue, over, order by order date rows between unbounded preceding and current row as cumulative system from orders.
Let's say we want to group our employees into 4 groups based on their salary, those quartiles we talked about. Which window function would we use, and what would the query look like?
For that, you would use the NTILE N function, where N is the number of groups you want. So for those quartiles, the query would be select name, salary, NTILE 4, over, order by salary deci, as quartile from employees.
How would you find the average salary for each department in the company using a window function?
You'd use the AVG aggregate function with the over clause. But to calculate the average separately for each department, you would use partition by department. So the query would be select name, department salary, AVG salary over partition by department as AVG salary from employees.
Building on that, how would you find the difference between each employee's salary and the average salary for their department?
You can do this by combining the employee's salary with that department average that we just calculated. So you subtract the average salary window function from the individual salary. Select name, department, salary, AVG, salary over partition by department as salary diff from employees.
How would you calculate the percentage of total revenue that each order contributes?
To get the percentage of total revenue, you would divide the revenue of the order by the total revenue for all orders. You can calculate the total revenue using the SUM function as a window function over the whole table. Then you multiply by 100 to get the percentage. It would look like this. Select ordered revenue, SUM revenue over 100 as revenue percentage from orders.
And how would you calculate the running total percentage of revenue as each new order comes in?
For the running total percentage, you would first calculate the cumulative sum of revenue up to that order using SUM with an order by clause within the over clause. Then you divide this cumulative sum by the total revenue, which we calculate as a window function over the entire table, and then multiply by 100. Select ordered revenue over order by order over 100 as cumulative percentage from orders. Let's make things a bit more challenging. How would you find the top 3 highest paid employees within each department?
For this, you usually need a subquery. First, you would rank employees within each department based on their salary in descending order. You'd use a window function like rank, or row number, with partition by department. Then you'd have an outer query where you filter the results to only include employees whose rank is 3 or less. Select name department salary from. Select name department salary over partition by department order by salary des ESE as salary rank from employees as ranked employees where salary rank is 3. Now how about this? Can you calculate the difference between each employee's salary and the salary of the employee right before them in the salary order?
Here's where you'd use the lag window function. Lag lets you look at data from a previous row based on how you've ordered the results. So to find that salary difference, you would use select name, salary, salary lag, salary over, order by salary as salary diff from employees.
Okay, last one. How would you calculate a moving average of revenue, but over a specific time period, like the last 3 months? Well, our earlier examples used a count of rows. To do it based on time, like the last 3 months, you'd need to use date-specific functions that your particular SQL version supports. These might involve something like range between and specifying a time interval before the current row. The idea is the same. You're defining a window, but now it's based on time, not just row count. So for example, instead of AVG revenue, over order by order date rows between 2 preceding and current row, which gave us the average over 3 rows, a time-based version might look like AVG revenue over order by order date range between interval 3 months preceding and current row. This depends on what your database system allows.
These are all really good examples of how you can use window functions to answer a wide range of questions. Now, let's try a couple of scenario-based questions to make sure you understand how to apply them.
Great idea. Scenario 1. You need to rank all the employees in your company by salary, but you want separate rankings for each department. How would you handle that using window functions?
We've already talked about this one. The key here is that partition by clause, along with a ranking function like rank or row number, the query would be select name, department, salary, rank, over partition by department order by salary dispatch as department rank from employees. The partition by department part makes sure the rankings are done separately for each department.
Okay, scenario 2. Now you want to track the cumulative total revenue for your online store for each month. And let's say your orders table has a column called order date. How would you calculate this cumulative monthly revenue?
To do that, you first need to get the year and month from the order date. Then you can use the SUM function with the over clause, and you would order it by this year-month value. The query might look something like this. Select staff time % per day order date as order month as sum revenue as monthly revenue over order by staff times order date as cumulative monthly revenue from orders grouped by order by order month. This first groups the orders by month and calculates the revenue for each month. Then it uses a window function to get the running total of those monthly revenues.
These scenarios are really helpful for understanding how powerful and flexible window functions are. So as we wrap up our deep dive, what's the most important thing you want our listeners to remember about window functions?
The main takeaway is that window functions are an incredibly powerful tool for doing calculations across related rows in SQL without losing those important details about each row. They're essential for tasks like ranking, calculating running totals and moving averages, and doing advanced analysis within groups of data. You can really unlock insights that would be much harder, if not impossible, to get with regular aggregate functions.
I completely agree. They add a whole new dimension to your data analysis. And here's a final thought to leave you with. How can you apply these ideas of window functions to the data you work with or the things you're interested in? Think about data sets that have a natural order, like data that changes over time or data that has built-in categories that you want to analyze. Could you use ranking to find the top performers in different groups? Could running totals help you track how key metrics are growing? What trends could you discover by using moving averages to smooth out noisy data? We challenge you to explore these ideas with your own data. Maybe even try out some of the more advanced window functions that your database system offers. Play around with defining different windows for your analysis. You never know what insights you might uncover. Thanks for joining us on this deep dive today.